Hello everyone. So today we are going to continue with the AI system. Here we are going to implement a behavior using behavior trees to chase the player. When the NPC characters see us, they will chase us and attack us, and once we are dead, they will just put back the sword and go back to their original location and just continue to wait there, just like this. So that's what we are going to work on today. And here, as I said, we are going to set up the behavior tree and the Blackboard component and connect it with the NPC AI controller and develop few behavior tree tasks to activate gameplay abilities from the behavior tree itself. So these are the things that we are going to work on today. And before we get started, I'd like to remind you, you can download the project files of this project and all other thousands of projects that I have done from the Patreon page. I'll leave the project file link in the description below. To the date, there are closer to 2000 videos, and for each video you can find the project file in the Patreon page. And this episode is a part of this action RPG with gameplay ability system tutorial series I'm doing. You can access the full tutorial series for free in YouTube in my channel. I'll leave this link also in the description. And let's get back to today's tutorial. Okay, so first thing I need to do to start implementing some advanced behaviors for the NPC characters is starting a behavior tree. So I'll call this PT NPC, and also to work with this behavior tree and to communicate with that, I'll define a Blackboard BB NPC. So in case you are not familiar with behavior trees and blackboards, basically behavior trees are used to represent the decision making process of AI characters. So by representing their decision making process in a tree structure like this, it's easier for us to understand and debug how the process happens rather than just trying to code it in direct blueprints or C++. So you will understand as we start working on these things. And also this Blackboard is here we can define different types of variables, and we can update values for these variables, so that variables will be used by the behavior tree to maintain and determine the state of the character. So here as the Blackboard asset, I'll set BB NPC. By default we have self actor. That means this will always keep a reference to the character or pawn who is currently using this behavior tree for AI or inside the AI controller. Okay, now in the Blackboard I'll add another object variable. I'll call it target actor, and under the key type I'll set it the base class to a actor, just actor object. Okay, now in the behavior tree what I'm planning to do is here I'll add a selector node. So execution will start from the root, and selector node will execute only one of the child nodes of this under this selector node, and if one node is activated, others will be ignored. So we can have multiple nodes under this based on different conditions. So for example, here I'll add a sequence. So sequence will be executed all their childs from left to right. unlike selector, sequence will execute everything. So here, this sequence, as I said before, I defined a target actor and I want to execute this sequence if I don't have a valid target actor. So here I'll add a decorator. It's like a if condition that would check before executing this sequence. If that condition is true, this sequence will be executed. Add decorator and Blackboard. So a Blackboard decorator. So the Blackboard, the condition here we are checking is set. So we can check if target actor is set. So actually this one I want to check if the target actor is not set. If we don't have a target actor, we just want the AI character to just wait without doing anything. And I'll add another sequence here also. I'll add a decorator, a Blackboard decorator. Here I'll choose target actor is set. So that means we have a value in the target actor. If that is the case, we need to execute this. So here by target actor, what I mean is in this AI controller, through the perception system, we determine other characters for this NPC. So for now we don't have any other character, it's just player. So therefore I'm going to consider whoever detected by this perception system as an enemy, and then I'm going to use this enemy and assign to this Blackboard target actor variable. That's what I'm planning to do. So after we set that, here I'll have to implement a way to equip the sword and chase whoever the target actor and attack him. That's what I want to do. Okay, let's do that step by step. Now first we need to tell this AI controller to use this behavior tree I just defined. So here under on possess event, this will be executed when this AI controller is possessed. This AI controller possess a pawn or a character. So usually it would be same as begin play for NPC characters, but only after AI controller start controlling a pawn, this will be called. So here run behavior tree. Now here as the behavior tree asset, I'll select the only behavior tree that we have in my project. Now without doing anything, let's just play and see. Now you see the NPC character is executing this branch, this node, because we haven't assigned any value to the target actor. Okay, now let's assign a value to the target actor when we detect an actor here from here. So I'll add a branch and use this successfully sensed value that is coming from this on target perception updated for break, and get this stimulus break and successfully sensed. If this is true, that means we would be seeing a character or actor, whatever a stimulus source that would be represented by this target. So now I can get Blackboard set value as object, because I selected the key type as object. So therefore I need to set the value as object, and as the object value I'm gonna put this target, okay, and key name, make literal name, use the same name as here, target actor, and we need to assign this if we successfully sense an actor, and if we lose the actor, I need to clear value. The key is this, so this will basically remove the whatever the value that we have set for this target actor variable. Okay, now here also I'll add a wait node so that we can see this branch is executing or not. Now here let me, can I put this like this and put the behavior tree. Now you see the NPC character is, let me stop, NPC character is over here. So if my player character move over here to the area this NPC character can see us, it should switch to this branch. Let's see, now it's executing left branch, and when I go here, it, yeah, see, it now executing the right branch. That's because now here you can see in the preview we have a value for the target actor, but still it's not doing any chasing and attacking. That's because we haven't implemented that yet. And to implement chasing, I can use this move to, this task comes by default. So here as the target Blackboard key, I can give target actor. So this AI character will try to move to the target actor and acceptable radius. So that means in order to consider that we have moved to that target, what's the minimum distance from the NPC character to the target character, the move target it should have. So I say like 250. Okay, but still this will not work because we haven't put a NavMesh to our scene yet. So let me put a NavMesh first. In case you don't know, NavMesh is like a volume. Inside that volume, Unreal will calculate data that is required for AI navigation. So this, when you press P, you can see the generated NavMesh, but it does not cover the entire area. So let's go to the top view so we can see. I'll set this to, I don't know, 500. That's too much. 250 seems fine. 250. Okay, if I go to the side view, 30. Not really, I only need to cover the ground, so maybe 20, 15. Yeah, this should be enough. So if I go to the perspective mode, now you can see everywhere the NavMesh, generated NavMesh. If I press P again, that will be hidden. The NavMesh will not be displayed. Okay, now yeah, now this should work. Let's try. Okay, he saw us and he's coming to us, see? Alright, but he's not attacking because we didn't do that part yet. Alright, and that's what we are going to do next. And one more thing, the equip sword part still happens in our AI class itself. That's not the way I want to do it. I want to make the character equip sword in the behavior tree because that's a decision the AI should make. So let me delete this. And then here, so how do we activate a gameplay ability from here? Well, let's create a generic task to activate a gameplay ability. So bt task activate ability. Right here I can override receive execute AI. From here I can access the controlled pawn. So from the pawn we can get ability system component, and if this is valid, we can activate abilities by tag. Try activate abilities by tag, and then we can promote this to a variable. So I'll call it ability tags and I'll make this public, and after that finish execute. Okay, so now I should be able to use this task to activate abilities from the behavior tree. pt task activate ability. Okay, and here under ability tags, now I can give under weapon input weapon equip. This is the ability that I need to activate. This is too big. But if I give a name equip, yeah, but still it's big. That's fine. Okay, so now let me just duplicate this and put here. Maybe after waiting 5 seconds it should put back the sword in case I lost the target. So this should be unequip and the tag should be unequip. Alright, now when the NPC see me, he should equip the sword and come at me. Yeah, he did equip, but he's not coming. Why? Oh, this should return success, I think. Yeah. Yeah. Let's see. Yeah, he's coming. Okay, now we have a way to activate abilities from the behavior tree, and let's try to lose him. But yeah, he keep coming. Yeah, we can't lose him. Okay, but that's a problem for another day. Now let's just focus on making him attack. So once he reaches us, he should attack. So how do we implement that? Same as using this. Maybe after he reached to us, we should make it wait like some random amount of seconds, maybe 0 seconds or maybe 2 seconds, and then PT task activate ability. So I'll make it do a light attack. Input light attack. Oh wait, not light, just should be light. That's wrong. How can I rename this? Light attack. Oh, I have to restart it. Okay, save or restart. Right. Assets were open. Alright, we were doing this and light attack. Input dot light attack. Okay. Now actually that's all. So let's see if we can do the attacks. It's coming and attacking. Yeah, great. Okay, I died and he keep attacking. That's because there is no way, we haven't still implemented the way to say the character is dead, but we have the character's death is managed using this death gameplay ability. Here we assign this 𝐠 gameplay effect. So here we add character.state.dead tag to the character when the character is dead. So if we can do some check here to see if the target is dead, then we can clear out the target actor, so that will stop the attack behavior. So for that, let's add a new task, PT task. I'll use the blueprint base as the parent. I'll call it check target. Okay, now here I'll add a function. I'll override this receive execute AI, and also I'll add an actor variable target actor. This should be from the type of actor and make it public. So now I want to check the target before we do the attack. So here check target. Now here we can assign the target actor. Wait, what's this? Oh sorry, this is not the way to assign a Blackboard value. So we can make it Blackboard key selector, and then get as actor, get Blackboard value as actor. Now we should be able to assign target actor to that. Yeah, see, it's already selected. That should be because of the name. Okay, now here we can get ability system component and we can check as tag has animation gameplay tags. So now here make literal container and select character state dead. So we can check if the state is dead. If yes, we need to clear out this target actor, so target actor variable that would stop executing this node and it will start executing this part. So basically it will stop attacks. So yeah, I'll again get the target actor. If this is true, clear Blackboard value. Okay, if this is false, nothing should happen, just finish execute with the success. Here finish execute with no success. Let's try this. Okay, now let's test. It's coming and let's wait until we die from the attacks. Okay, now the guy is not doing the attacks anymore and he put back the sword and wait. All right, so what else we should do? Okay, let's make him move back to the original location. Here I'll add a new key vector. I'll call it initial location. So and yeah, initial location may not have a value, so we need to ensure that it has a value, it has a proper value. So in the on process I'll get Blackboard and then set value as vector, key name make literal. Let me copy this. Process phone get actor location. Alright, now in the behavior tree after unequip I'll make it move to initial location. That should work. Let's try again. Okay, he's coming. Let's just die. Okay, waiting 5 seconds, put back the sword and he's going back. Great, he went away. I'm dead. Alright, I think that's enough for this episode. And thanks for watching. As always, updated project files will be available for the download in the Patreon page. Link would be in the description below. And don't forget to like and subscribe. So in upcoming episodes we will continue to work on more features to the AI system. And now that we have a mechanism to make the NPC character attack us, we can implement blocking system and parrying system, all those things that you usually see in a melee combat. So yeah, let's see how to do those things in upcoming episodes. And goodbye.